Hello guys, welcome back. So if you have watched the lesson video for chapter 3 property of waves, we can go ahead and do some practice problems for this chapter. Now, question 1. The diagram represents a microwave traveling in free space from A to B. So the distance from A to B is 0.6 meters, and they want you to calculate the wavelength of this microwave. So you should know that the wavelength on a wave diagram is simply this. Okay, so right now, since it is from A to B 0.6 meters, let's count how many wavelengths there are. So this is one wavelength, this is two wavelengths, this is three wavelengths, and then this is half of it. Okay, so meaning that 3.5 wavelengths is equals to 0.6 meters. So we're trying to find out the wavelength of 1, so it will be 0.6 divided by 3.5. Okay, so your answer would be 0.17 meters. Okay, the second question, state the equation linking wave speed, frequency, and wavelength. So it is simply V is equals to F lambda. Now number C, calculate the frequency of the microwave, and the speed of microwave or any wave in free space is 3 into 10 to the power 8 meters per second. Even if this information is not given to you, you should know it. Okay, so if V is equals to F lambda and we want frequency, so rearranging the equation would give us F is equals to V over lambda. Okay, so V is 3 into 10 to the power 8 meters per second divided by your wavelength, which is 0.17 meters. Alright, so if you put it in the calculator, you would get 1.7 into 10 to the power 9, and the unit for frequency is hertz. Okay, now question 2. The diagram shows you part of a water wave. Which letter represents the wavelength? So it's fairly simple. The letter B represents your wavelength. Which letter represents the amplitude? The amplitude is the maximum distance from your resting position, so it is A. Now, this water wave is a transverse wave. Other waves can be longitudinal. State a similarity and a difference between transverse wave and longitudinal wave. Include diagrams in your answer. So, if you want to give a similarity between transverse wave and longitudinal wave, the similarity would be, alright, give me a second. The similarity would be that, that both waves, okay, can be reflected, refracted, or diffracted. Okay, so that is your similarity. Now, how about the difference? Okay, so the difference, sorry. So the difference is simply that transverse waves, in transverse wave, okay, in transverse waves, the direction or the vibration direction is perpendicular to the direction of the wave energy. Okay, and in longitudinal wave, we can write the opposite of it. In longitudinal waves, the vibration direction is parallel to the direction of the wave energy. Alright, that sums up the difference between difference and similarity between transverse wave and longitudinal wave. Okay, alright, so include diagrams in your answer. This is also very commonly asked. So to draw a transverse wave can simply be drawn as this. So this is your direction of the wave energy, and then for transverse wave, your vibration would be perpendicular to it. So you can draw arrows like this to represent your transverse wave. Now, as for longitudinal wave, you can draw it this way. This is the direction of your wave, and since your vibration is parallel to the direction of your wave energy, it can simply be drawn as this. Alright. Question 3a. Now the diagram shows you part of a water wave. What is the amplitude of the wave? Okay, so we've done this before. Let's do it again. The amplitude is the maximum height that you can reach. So it is 2 centimeters. Sometimes students tend to make the mistake of trying to count the whole thing, okay, which is wrong. Now, what is the wavelength of a wave? Okay, so for the wavelength, you start at one position and then tries to end up in, you stop counting when you reach the same point on your wave. So let's talk about it, okay? So this starts at 0, it ends at 8 centimeter, so it is 8 centimeters. Just to make yourself sure, try to count another wavelength. So this time, let's try to count this place, okay? We're going to start from this place, so this is 0 and 4, half of it will be 2. 8 and 12, half of it will be 10. This will be 6. So if you start from here, you should stop counting your wavelength at this place. So this is 10 minus 2 is also equals to 8 centimeters. Make sure that you got this right in your exam. This is very commonly asked. Question 3b. The diagram shows you part of a water wave. What is the period time of the wave? So the period of the wave is simply the amount of time that you take to travel one wavelength. So in this case, it is 0.4 seconds. Sorry. Number 2. What is the frequency of the wave? Since you already know your period, you can use the formula F is equals to 1 over T. Now 1 over T would be 1 over 0.4. You would get 1 divided by 4. You would get 2.5, and the unit for it will be Hertz. Alright. In exams, make sure that you write down the original equation, and if you need to rearrange it, please rearrange it. You are still going to get a lot of marks from it. Question 4. Calculate the period of a wave with a frequency of 200 Hz. So your frequency is 200 Hz, and you want to find your time or the period. So the formula or the relationship between frequency and period is F is equals to 1 over T, meaning that T is equals to 1 over F. Okay, so let's substitute here. It would be 1 over 200 Hertz. If you put it into your calculator, you would get 0.005 seconds. Question 5. A tuning fork creates sound waves with a frequency of 170 Hz. If the speed of sound in air is 340 meters per second, calculate the wavelength of the sound wave. Okay, so let's write down what we know here. So the frequency is 170 Hz. The velocity of sound in air is 340 meters per second, and is asking you to calculate the wavelength. So the formula that you should use is V is equals to F lambda, and if you want wavelength, rearrange the equation, is equals to V over F. You are still going to get marks for writing this down and writing this down, so in exam, please don't be lazy. Alright, so your velocity now is 340 meters per second, and the frequency for it is 170 Hz. So this will be 2, and since this is wavelength, your unit would be meters. Let's read question 6. The current required to charge an electric toothbrush has a frequency of 27,000 Hz. Now the toothbrush vibrates, sorry, it's not tooth, okay? Vibrates at the same frequency when it is being charged, and there is a pulse in the current every 1.5 milliseconds. Whenever you see units such as kilo or milli, okay, just try to circle them because you know that you need to convert those units and calculate the frequency of the pulses. In physics, the questions will sometimes give you information which are not necessary, and you should be able to ignore them. Right now, it's asking you to calculate the frequency of the pulse, and they already told you the time period for the pulse, which is 1.5 milliseconds, so there's no need for this information. Okay, so as usual, F is equals to 1 over T, 1 over, since this is 1.5 and milliseconds, you're going to multiply it with 10 to the power minus 3. So your frequency would be, put it into your calculator, 1 divided by 1.5 into 10 power minus 3. You would get 666.67 Hz. Alright, question 7. A person observes water waves on the surface of a pond. 18 waves pass by the person in 12 seconds. So calculate the frequency of the waves and give the unit. So we're simply going to divide the number of waves by the time it takes to travel. So it will be, the frequency would be your number of waves divided by your time period. So it is going to be 18 waves divided by 12. You would get 18 divided by 12 in calculator would give you 1.5, and the unit of frequency would be Hertz. A radio station uses a short wavelength radio for broadcasting information. The wavelength is 25 meters. So write down what you know is 25 meters, and the frequency is 12,000 kilohertz. Make sure that when you see these kind of units, kilo, milli, mega, try to circle them because you might forget to write down conversion units for them. So since this is 12,000 kilohertz, it's going to be 12,000 into 10 to the power 3 hertz. Calculate the speed of the short wavelength and radio wave. So you want V. As usual, V is equals to F lambda. So your frequency is 12,000 into 10 to the power 3 multiplying with 25. 12,000 then power 3 multiply with 25, you will get 3. Now there's a lot of zeros, so make sure that you count them right. It would be 3 into 10 to the power 8 meters per second. Alright. Now this is a question about ripple tank experiment. So let's read the question. A student investigates different properties of waves. He's using the ripple tank to investigate diffraction. Waves in the deep part of the ripple tank have a speed of 6 centimeters per second and a wavelength of 4 centimeters. Waves in the shallow part have a speed of 4 centimeters per second. The frequency is the same for the deep part and the shallow part. Show that the wavelength in the shallow part of the ripple tank is approximately 3 centimeters. So this is a show that problem. So you already know what your final answer should look like. It's just a matter of how to get there. Okay. So since you know two properties for the deep part, let's try to write it down. For the deep part, the velocity is 6 centimeters per second with a wavelength of 4 centimeters. From this, you can find the frequency. So V as usual, is equals to f lambda, and f is equals to v over lambda. In this case, f is equals to v is 6 centimeters divided by 4, so you would get 1.5 hertz. Alright, so they already told you that the frequency of the waves stay the same. So for the shallow part, okay, the velocity, or sorry, the speed is 4 centimeters per second. We need to find the wavelength in order to prove that it is 3 centimeters. So v is equals to f lambda. This time we want the wavelength, so lambda is equals to v over f. So lambda is equals to v over f. In v, we are going to substitute 4, and in frequency, since the frequency of the wave stay the same, we can just substitute the one that we have found for the deep part. 4 divided by 1.5 would give you 2.67 centimeters, which is approximately equals to 3 centimeters. So it's already shown. Now, a student investigates different properties of waves. He used the ripple tank to investigate diffraction. Now, the ripple tank will produce plane waves, but he's going to put a barrier here with a gap in it. The student keeps the wavelength constant, but he is varying the size of the gap in the barrier. Complete the diagrams to show what happens to the planes when waves go through small gaps and large gaps. As I mentioned in the lesson video, if the wavelengths are much larger than the gap, or if the gap is very small, we're going to have many waves which are curved like Wi-Fi router signal. Now, but if your wavelength, okay, and the gap is almost the same, or if the gap is very large, you won't have much spreading. So your waves will look like this. Alright, so those are some of the brightest problems for chapter 3 properties of waves. I hope you learned something from seeing the problems here, and I'll see you guys again next time.